So today we are going to learn about the four equations of motion. And later, after writing them down, we will come to a general explanation of how they come to being, which means we will discuss about the derivatives, how we derive them. So the four equations of motion are S equals Vt, A is equal to V minus U over T, S equals ut plus half times A times t squared, and of course V squared equals U squared plus 2 times A times S. Now, what do these symbols signify? S stands for displacement. Velocity V is final velocity, and U is initial velocity, and T is basically time. Needless to say, A stands for acceleration. Alright, now one thing that I forgot to mention is that this V over here for S is V times T. V is the average velocity, which is denoted by the denotation V bar, which means this signifies what? Average velocity. Alright, now, so these are the four equations of motion that come into being for 2D objects moving in a certain plane. Now, we want to come to the explanations of how they come into being, which is their derivatives. By default, we know that velocity is basically the rate of change of what? Displacement. Which means that which means that velocity, if denoted by V, velocity is basically S over T, which comes where, of course, S means the change of displacement and T is the change of time, which means S is Vt. Alright, so we have our first equation of motion, S equals Vt. Let's put that down as equation number 1. Now, talking about the second equation of motion, we need to first talk about what is acceleration. Acceleration, by definition, is basically the rate of change of velocity, which means if acceleration is A, final velocity is V, and initial velocity is U, and it takes time t for the object to reach the final velocity V from initial velocity U, then this equation stands. So by definition, we can say that this is our required second equation of motion. And if we would like to make some modifications to it, this will stand as V equals U plus AT. We can check that out by just doing some simple algebra. Alright, now comes to the third equation of motion. Now, when we talked about the first equation of motion, which is this, we said that S is basically V bar times T, where V is the average velocity when it comes to an object not moving in a uniform velocity. So we can write this down as S is basically, let's take U as the initial velocity and V as the final one, divided by 2, since we are taking the average, times the time taken, right? Now, here's the thing. We know from the second equation of motion that V is basically U plus AT. I'm talking about this equation, right? So, if we input this into this equation, so we get that S equals U plus AT over 2 times T. So we get that 2U plus AT times T over 2 is basically s, or s is 2u by 2 times t plus at times t over 2. 2 and 2 divides and cuts off themselves, so we remain with s equals ut plus half times a times t squared, which is our required third equation of motion. Alright, so we're done with our third equation of motion. What we are left is with the fourth equation of motion. So how do we actually derive the fourth equation of motion? Well, you just work with equation number 3 and use the second equation of motion. Alright, so we know from the third equation of motion that s is ut plus half times a times t squared, and the second equation says that v equals u plus at. Now, what we are going to do is represent this t in terms of the other variables in the equation, which means we say that t is v minus u divided by a. Alright, what we are going to do is we input this equation into this, which means that this entire thing stands to be s equals u times, s equals u, and if we input this thing inside here, we get that v minus u over a plus half a times what? V minus u over a squared. Alright, we just do some simple algebra, so we get that uv minus u squared over a plus half times a over a squared, and inside the bracket goes v minus u whole squared. We cut these a's off and we get a over here, which stands uv minus u squared over a plus v squared minus 2uv plus u squared. We just inputted the formula a minus b whole squared is a squared minus 2ab plus b squared over here. And in the denominator, we have 2 times a. So we have s equals uv minus u squared times this 2 plus v squared minus 2uv plus u squared, and we have 2a in the denominator. We input the value, we move on with this thing, and we multiply both sides with 2 times a, so we get s times 2a is 2uv minus u squared times 2, or we could just write 2u squared plus v squared minus 2uv plus u squared. We again get 2as equals 2uv and minus 2uv cancels themselves out. We get that v squared and of course minus 2u squared and plus u squared equals minus u squared. We do some jumblings and other sorts of tricks, and it's just normal algebra, and you get that v squared equals u squared plus 2as. And here we go. So these are basically the 4 equations of motion derived. Well, if you like my video today, then please, of course, hit a like button and subscribe. And of course, I'll be back again with another video of physics. Thank you.